Today I give the presentation regarding routing information protocol version 2. So outline of the presentation here is dynamic routing protocol, RIP, distance vector, dynamic routing, RIP version 2, and the summary of the RIP version 2. So the RIP version 2, basically it is work on the classless addressing. So here we can discuss about the basic operation of the RIP and determine which networks are available during the initial network discovery phase and describe the process by which the distance vector routing protocol learn about the networks and configure the RIP version 2 with classless inter-domain routing scheme. So evolution of the dynamic routing protocol used in since from the network of the late 1980. So they can categorize the routing protocol classification based on the two parts. One is the interior gateway routing protocol, another is the exterior gateway routing protocol. Under the interior gateway routing protocol, they can divide into the two parts. One is the distance vector, another is the link state routing. So in distance vector, we use the IPv4 under that RIP version 2, and in the link state routing, we can use the OSPF. So that is the diagrammatically we can describe the dynamic routing protocol broadly classified into the two parts, interior gateway IGP and EGP is the exterior gateway routing protocol. Under the IGP interior gateway routing protocol, one is the distance vector routing, another is the link state routing protocols. In distance vector routing, discuss about the RIP version 1, which is work on a classful addressing, and the next RIP version 2, which is work on the classless inter-domain routing scheme. So, the classful routing protocol will not send subnet mask information in their routing updates. So that's why we can use only RIP version 1 and IGRP are classful, created when network based on the class A, B and C. So cannot provide the variable length subnet mask in the case of classful addressing and create problem in a discontinuous networks. So when we want to create a discontinuous topology, when we want to create a discontinuous topology, we can use the RIP version 2. So in classless routing protocol, the routing protocol includes the subnet mask information in the routing updates. So here we used RIP version 2, EIGRP, OSPF. So which support the classless inter-domain routing scheme. So in distance vector routing protocol, how the RIP version is the first generation of the protocol and which is work on the classful addressing, and RIP version 2 which is work on the classless addressing. So when we can discuss about the two routers, we can connect it into the serial interface and with the help of serial interface line 001, and the another router which are connected to the 172.16.3.0/24, which is used for subnetting. So here we can use the RIP version 2 in the case of classless addressing. So it is the distance vector routing protocol. In this case, share update between the neighborings, not even the network topology, and some send periodic update to broadcast of the IP address to 255 subnet mask of 255.255.255, even if the topology has not changed. Update consume bandwidth and network device for CPU resources. So RIP version 2 and EIGRP, which is used for the multicast addressing. In case of RIP version 1, which is used for the broadcasting. So here we go to this topology. In this topology, there is a 3 routers, and we can take a different address. The router, the first PC 1, which is connected to the router based on the gigabytes and fast gigabytes, and the network address is 192.168.10.0. Another network which is placed between the router 1 to router 2, it is 10.0.0.0. Now, in the case of router 2 to router 3, it is 12.0.0.0. And router 3 to router 1, again, we can take the networks of 11.0.0.0. So these are connected to the different router connected to PC. In this topology, when we want to packet transfer from the PC3 to PC1 or PC1 to PC3, here it is a discontinuous topology, and in the case of 10.0.0.0, we can use the subnet mask of /30. So in that type of case, we can use the classless interdomain routing scheme. So here we can use the version 2, RIP version 2, so we can easily transfer the packet from the PC1 to PC3 and PC3 to PC2. So routing protocol matrix. Matrix is measurable value that is assigned by the routing protocol in the different route based on the usefulness of the route. So here in this case of routing protocol, we can use the overall cost of the path and from the source to destination, and that is the best route with the lowest cost. Our main aim is to find the best path with the minimum cost. So in a distance vector routing algorithm, here there is a two router. One router is connected to the fast Ethernet at the IP address 172.16.1.0/24. It is updating, and router 1 to router 2, which are connected to the serial interface line of 0.0.0, and the network IP is 172.16.2.0/24, and router 2 again connected to the fast Ethernet with the network is 172.16.3.0/24. So one is the RIP basically used for the Bellman-Ford algorithm for the routing algorithm, and IGRP and EIGRP is used the diffusion update algorithm, and that is developed by the Cisco. Now in the routing information protocol, what is a cold start? Cold start is that propagate the routing table, and they cannot be updated immediately. Here in this one, they show that the network 10.1.0.0, which are connected to the fast Ethernet, and the 10.2.0.0, which is connected router 1 to router 2 with the help of serial interface 0/0/0. Now here host count is 0. After the router R2, which is interconnected to router R1 and R3, the router R2, which connected to the serial interface of the 0/0/0 with a network of 10.2.0.0, and another R2 is connected to the serial interface 0/0/1 with the address networks of 10.3.0.0. Now the R3 router is connected to the two parts. One is the serial interface of 0/0/1, and the another is connected to the fast Ethernet with the IP with the networks of 10.4.0.0. In a cold start, say in the routing protocol, you can propagate the information update, but it will take some time. So that's why it is called as a cold start. Next is the network discovery. So here also we can take the three routers, and the different address they are connected to with the help of the networks interface, and there is a number of host count. So in the router R1, we can send an update about the first they are connected to the fast Ethernet of 10.1.0.0, and they are connected to the serial interface of 0/0/0. So they can send the update about the network 10.2.0.0 out of the fast Ethernet of 10.1.0.0. Similarly, the R3 networks, they are connected to the two ports. One is the fast Ethernet, another is the serial interface of 0/0/1. So here we can create one routing table with the network interface and host count. So here the host count is 1. So store the network of 10.3.0.0 in a routing table with a matrix of 1. So the routing information protocol version 2 have certain characteristics why we can use the routing information protocol version 2. One is the timer, another is the convergence, third is the count to infinity problem. So these all are the host count. So these are the concerns we can use in the routing information protocol version 2. So router running in the network discovery with a number of routers are connected with the help of the initial exchange of the data between the router, one router to another router. So they can send the update about the network of the 10.4.0.0 out of the serial interface connected to the 0/0/1. So they can send an update about the 10.3.0.0 out of the fast Ethernet of the 0/0. So how we can connect it in the discontinuous topology? We can use the routing information protocol version 2. So extending the routing information. So here the send the update about the networks of 10.1.0.0 out of the serial interface they are connected, and they can send the update, the information between the 10.2.0.0 and the 10.3.0.0. So we can classify with the help of this topology. So here in this topology we can use the different configuration based on the routing. So in first router we can just we can add the WIC-QT whenever the switch is off in the router. After that we can configure of the router 1. We can go for enable command. Then we can configure terminal. Then we can give the different router name, router 1, router 2, whatever the number of router. We can change the host name and the router. Then we can connect it. This first. Now this one is connected to the gigabit Ethernet, and this router again connected to the serial interface of 0.0.1 and 0.0.0. One is connected to 0.0.0, another is connected to serial interface of 0/0/1. So here we can take the three in a routing table. Three parts we can consider. One is connected to gigabit Ethernet, another is connected to serial interface, and third one is connected to serial interface 0/0/1. So same thing we can perform here. In the IP address of 192, first it's connected to the interface of the gigabits of 0/1. Then this router is, you can use the IP address, the default book address is 192.168.10.1, and subnet mask is 255.255.255.0 after no shutdown. Then the another router, the same router we are connected to the router 1 to router 2, which are connected with the help of serial interface. So, and the network is also the 10.0.0.0/30. So here we can use the IP address of 10.0.0.1 and 255.255.252 because we can use the subnet masking. So clock rate is again given the 128.000 and no sir. The same router we can connect it to the another serial interface of 0/0/1, and IP address is the another network is 11.0.0.0. So here the default router password IP address as given 11.0.0.1 and subnet mask is 255.255.255.252. Again set the clock rate and no shutdown. So these type of configuration we can carry out in all the three routers, because first router they are connected to, one is the gigabit Ethernet, another is the serial interface 0/0/0, serial interface 0/0/1. Now this router it is again connected to 1 gigabit Ethernet, serial interface 0/0/0 and serial interface 0/0/1. The that router is also connected to the two serial interface and 1 gigabit Ethernet. After we can connecting all this one, the routing information protocol version 1 should not travel the packet from the PC1 to PC2. So what we can do, we can use the version 2, because version 2 it is work on the class-based inter-domain routing scheme. So the next we use the router RIP and version 2. And then we can mention the network address of 10.0.0.0, another network 11.0.0.0, and they are connected to the 1 gigabit Ethernet 192.168.10.0. So now we can create a passive interface of gigabits of 0/1, and at the last we can also mention the no auto summary. So this part we can perform in all the three routers, and then we can find the final configuration of the packet travels from the one source to one PC to another PC. So next is the achieving convergence. So the convergence is the time is to take the routes to share the information and calculate the best path to update the routing table. So we can incorporate the achieving convergence. So a network is not be completely operable until the network has converged. So here the routing in configuration mode. Here in this case, the router 1 are connected to the switch and they are also connected to router 2 and they are advertising the router 1 networks. So what we can do in the router, we can first go to enable count, then we can conf t, we can enter the configuration mode and we can enter the router RIP. So in a router RIP, whatever the networks are connected into the router, we can mention the networks and IP and the network address. So examining the default RIP setting, to verify the RIP setting ARS, what we can do, we can write the show IP protocols. So they can mention the IP protocols and they can also show the IP routes and begin to the gateway. So that's command we can also examine to the default routing information protocol setting. So the enabling and verifying the routing information protocol version 2 on router R1, what we can do, first we can use the router RIP in config command, then version 2, after that we can mention the network address. So the last is the disabling the auto summarization. To modify the default routing information protocol behavior of the automatic summarization, we can use the no auto summary router configuration mode command. So no auto summary router information command is a very compulsory command in the routing information protocol version 2. After we can setting the version 2 and the network address. So that command has no effect when using the routing information protocol version 1. So configure the passive interface and the topology. There is a 3 routers and the 3 switches are situated. What we can use in the config protocol of the router 1, router RIP, then passive interface of the gigabits of the 0/0. After we can sending out unlimited update on the LAN, impact the network in 3 ways. One is the wasted bandwidth, another is the wasted resources, and third one is the security risk. So it is how to propagate a default route. So here the router R1, they are connected to the internet. So here what we can do, we can use the default route. So how the default route, they are set to the IP route 0/0.0.0.0. So we can also give the same subnet mask and then we can send the router RIP and default information can be originated in the router config command. So in a dynamic routing protocols, RIP version 2, it's dynamically source distance vector routing protocol. Metric is hop count and maximum hop count is 50. And uses of the 224.0.0.4 for multicasting of the routing table. So whenever there is a 2 and more than 2 routers, we can transfer the packet from one side to another side. There is one IP address they can also use, which is called as a 224.0.0.9, which is used for the multicasting in the case of routing information protocol version 2. Apart from that, routing information protocol, we can also use the convergence, we can also use the count infinity, and we can also use the count infinity and timers. So, thank you.